Hey guys, this video is over the specific heat capacity calculations. Alright, so specific heat capacity is the amount of heat required to raise the temperature of 1 gram of a substance 1 degree Celsius. So if you don't have these in your notes already, I would pause the video and make sure you write it down between me going through this, because I'm going to go through it pretty quickly. Alright, so the units for specific heat capacity are joules per gram degree Celsius or calories per gram degree Celsius. And so joule is a unit for energy, and so is calorie. Calorie is not used as much anymore in the classroom academically as joules is, but calories is definitely used like for food and stuff like that. The only difference is the calories that you eat, I think, are 1,000 times more than these calories. So why they do that, I don't know, but they do. Probably because you don't want to see 200,000 calories on your bag of chips, your little bitty bag of chips. All right, so just for your information, 1 calorie is 4.184 joules. This is about to go away, so if you don't have it in your notes, write it down right now. All right. So the specific heat capacity for water, okay, is 4.184 joules per gram degree Celsius. This is the symbol for specific heat capacity. So it's a little S next to a big C, capacity, and that's specific because there are other there's a regular heat capacity and then there's a molar heat capacity. The only one we're going to use this year is the specific heat capacity. And so it takes water, 4.184 joules, for 1 gram of water to heat up 1 degree Celsius. So just like you would write 65 miles per hour means that you drive 65 miles in 1 hour, this is saying you have 4.184 joules for every gram to go up 1 degree Celsius. All right? And so this is only for water. All right, the formula that we're going to use to do these calculations is Q is equal to the specific heat capacity times the mass times delta T. Now, most of the time you'll hear me only refer to specific heat capacity as specific heat because it's a really long term. And so it's not that uncommon just to shorten it to specific heat, but it's the same thing. All right, so Q is heat. That's the specific heat. M is mass, and it's in grams. And delta T is the change in temperature. And so it's found by taking the final temperature minus the initial temperature. So you always take where you end and you subtract where you started. All right, and that's what delta means. It means to take the final minus the initial. That triangle is delta. Okay? All right, so for the examples, how much heat is needed to raise the temperature of 1,000 grams of water from 10 to 25 degrees Celsius? So we're looking for heat, which is Q, and this is our mass. Whoa. And then our delta T is equal to the final temperature minus the initial temperature. And so our final temperature is 25, that's where it ends, minus 10. And so our delta T is equal to 15 degrees Celsius. And I'm going to be looking for Q, right? So I've got Q is equal to, now since this is water, 4.184 joules for every gram. We want to bring up 1 degree Celsius, but we don't have 1 gram. We've got 1,000 grams. So I plug in 1,000 for mass, right here, right? The CS, oops. The CS for water is 4.184 joules per gram degree Celsius, and then our delta T is 15 degrees Celsius. So that means that this cancels out, the degrees Celsius, and grams cancels out, and if I put that in my calculator, I end up with, 62,760 joules. And you could even write that as 62.8 kilojoules. Either way works, okay? You probably, in higher level courses, you'll see it like this more than you'll see it written like this. So if it's a big number, we'll put it in kilojoules. All right, let's do another one. So we've got 0.5 kilograms of water has an increase of 7 degrees Celsius. How much heat was absorbed? So this time we're looking for heat again. So we're looking for Q. This is our mass. And this is our delta T. Because it says it went up by 7 degrees. The increase was 7 degrees Celsius. So it doesn't matter if you started at 20 and ended at 27, or you started at 120 and ended at 127, the change in temperature was still 7 degrees Celsius. So I'm looking for Q. That's what I don't know what it is. And my specific heat capacity for water is 4.184. My mass. Now, because this is in grams here, our mass has to be in grams too. So 0.5 kilograms, 1 kilogram is 1,000 grams. So we have to multiply by 1,000, or you just have to know that you move the decimal place forward 3 places, and so that's 500 grams. And then my change in temperature is 7 degrees Celsius. So grams is going to cancel out, degrees Celsius cancels out. And if I multiply 4.184 times 500 times 7, I end up with 14,644 joules, or you can write that 14.6 kilojoules. Okay? All right. Now we have 1,500 joules of energy is lost from a 0.12 kilogram object. The temperature decreases from 45 to 40. What is the specific heat of the object? So we're given Q this time, and we have mass, but we should use 120 grams instead of 0.12 kilograms because the decimal place has to move forward 3 places. And the temperature decreases from 45 to 40. So if the temperature decreases from 45 to 40, the delta T is going to be equal to the final temperature of 40 minus 45. So that goes down negative 5 degrees Celsius. And we're looking for the specific heat. So we're looking for CS, C sub S. Now, one thing that I haven't mentioned yet is the sign for heat. If heat is lost, that means it would have a negative sign. If heat is gained, absorbed by an object, then heat would have a positive sign. So if heat is lost, it's negative. So our Q is negative 1,500 joules because it's lost. And that means it's an exothermic process. It's losing heat. It's exiting. And that's going to be equal to the specific heat times the mass times negative 5 degrees Celsius. So if I multiply these two together, 120 times negative 5 degrees Celsius, I end up with negative 600 grams times degrees Celsius. So I'm going to divide both sides by that. And if I take negative 1,500 and I divide by negative 600, I get 2.5. My units would be joules over gram degrees Celsius, which is what I want for specific heat. So notice that the negative signs cancel out. You're never going to have a negative specific heat. You're never going to have a negative mass. You can have a negative temperature change. You can also have a negative heat if the heat is lost, but that's the only time. All right, let's do one more. Copper has a specific heat of 0.38452 joules per gram degree Celsius. If 17,500 joules of heat is absorbed by a 780 gram sample of copper, initially at 25 degrees Celsius, what is the final temperature? Okay, so this one is the specific heat. That's Q. It's mass. And this is the initial temperature. So we're looking for the final temperature. So the way that I would do this is I would look for this, the delta T. So I would plug everything in and look for the delta T. So it says we have 17,500 joules of heat and it's absorbed by the copper. So that means it's going to be positive. It's endothermic. And the specific heat is 0.38452 joules per gram degree Celsius. The mass is 780, and I'm looking for my delta T. So I'm going to divide by the product of those two. So if I multiply these two numbers together, I get 299.9256 joules per degree Celsius. I'm dividing that over here too. So joules cancels out. Now, the denominator of a denominator is a numerator. Okay, if you need help with that, I can show it to you, but I'm not going to worry about it right now. And so I get that my change in temperature is equal to 58 degrees Celsius. And so since heat was absorbed, the temperature should go up. And so if we start at 25 degrees and it has an increase of 58 degrees, that means that we're going to end at 83 degrees Celsius. Now, if we had lost heat, our delta T should be negative, and so we'd have to subtract it from our initial temperature. All right, so that's it. Let me know if you have any questions. You're basically just plugging this stuff into this formula over and over again and solving for different things. Most of the problems will be solving for Q. If you need the specific heat for nickel, because you need it for the worksheet that I gave you, it's just not on there. I must have gotten rid of it somehow. The specific heat for nickel is equal to 0.44 joules per gram degree Celsius.